Welcome back. In this video I'm going to show you two examples of how we deal with fractional addition and subtraction when we're dealing with fractions that have multiple terms in the denominator. So consider example 7 here. We've got z over 6 plus, and here's where it is, z minus 2 all over 3. So there's multiple terms up there. Now the way in which we deal with this is very similar to how we dealt with the fractions in example 5 and example 6. What we're going to do is we have two routes we could take. We could go this universal route here, which will get us to the right solution, but it might require a little bit of extra simplification later. Or we can go straight for the kill, and we can try and put one of these fractions as a common denominator with the other one. So I'm going to go that route because it's more efficient. So we've got z over 6 plus z minus 2 over 3. Now with this we ask ourselves, which is the easier fraction to have a common denominator with? And 6 is a bigger fraction, so I don't really want to mess with that. And 3 is a smaller one. Now think about it. 3 can fit into 6 twice over. So what we can do is we can multiply the 3 by 2. And that will give us a denominator of 6, and if we multiply the denominator by 2, we also do that with the numerator, just to keep everything in balance. We don't want to change the value of the fraction, we just want to change its representation. Now, we're going to get z over 6 plus z minus 2 all over 6, and we have to deal with that plus 2 or times 2 in the numerator, so it's going to become 2 times z minus 2 all over 6 now. Alright, we've got a common denominator, so I can write a single one down here, put a big line, and then put everything in the numerator. So, now in the past I've told you, when we've done this sort of thing, don't open up the brackets in the numerator. And the reason for that in the past was we wanted to do simplification first. Now if we look at this particular problem, what we notice is that, well, if we open up the brackets, what that's going to mean is that we've already got terms outside, such as this one here. If we open up these brackets, we can actually start collecting like terms, and it will make the expression simpler. So in this case, I'm going to open the brackets up and see what we can do. So I'm going to go z plus 2z minus 4. And that's still all over 6. Now collecting like terms, because we've got the z and the 2z, and go 3z, take 4, all over 6. And therefore, this is now our answer. Now we could try and simplify this a little bit more, but we'd end up getting fractions. So if we wanted to, we could go 0.5z, like so, minus, and that's going to be 2/3, or roughly 0.6 repeater. But we don't really want to do that because that's not the most exact way to answer it. So we'd probably leave it in this form here. So that's example 7 done. Now example 8, notice that we've got x plus 1 over 2 minus x minus 2 over 3. So in this example, we have two fractions with multiple terms within each numerator. So, and another thing we notice that the numerators are, both of the denominators I should say, they're prime numbers, so they're not divisible by one another. So the only route that we have to take here is we have to go the method where we multiply the two denominators, and then we have to cross multiply like so. So we don't have a choice here. So going ahead and doing that, we're going to go 2 times 3. Then we're going to go x plus 1 times 3. So it should be easy enough. We'll put the 3 out front, and then we'll go x plus 1 like that, just because it's a little bit neater. And put the negative symbol in there. Should have done that first. And then I'll go for the final term. So we'll put the 2 out front because it's shorter. And then we'll put in these brackets, so x minus 2. There we go. Alright, cleaning this all up, we're going to get 6 in the denominator. Then upstairs we're going to get 3x plus 1, x minus 2. Now we have to stop and think, is there any simplification we could do first, or do we just open up the brackets and would that help? Now looking at this, I can't see any simplification we could possibly do, so I think our next step is we open up the brackets and we see if we can collect like terms. So 6 is still on the bottom, and we're going to go 3x plus 3 minus 2x minus negative 2. So notice this little step here. There's a minus there and a minus there. So these two guys is going to be a double negative. Easy mistake to make. So that's going to become 3x plus 3 minus 2x plus 2 all over 6. Collecting like terms, 3x minus 2x is simply x plus 3 plus 5, or 3 plus 2 is 5 all over 6. And thus we get to our final answer here, x plus 5 all over 6. So much cleaner than what we started off with here. So this has been 2 examples of how we do fractional arithmetic, so adding and subtracting fractions where there's multiple terms within the numerators.